Today is our Sunday blockbuster series. So in the Sunday blockbuster series, we see the new chapter of modern pharmaceutics, which is packaging of the pharmaceuticals. Welcome back students to our new YouTube channel Pharma X Tech, the division of excellence. So let's start to the new chapter of modern pharmaceutics, which is packaging of pharmaceuticals. So let's start to this topic, packaging. So in that we first see the glass. So this glass is a barrier against the all elements except the light, and also the red color or amber color bottles protects against the light. And next we see the composition of glass. The glass contains sand like silica sand and soda ash means Na2CO3 and limestone CaCO3, and the culate. This culate is a broken glass. This culate broken glass is act as a fusion agent. Next one is oxygen. Oxygen is only one anion present in a glass, and if the presence of nitrous oxide, this nitrous oxide is a chemically resistant for the glass, and melting of glass is possible in presence of nitrous oxide. That means your NO. And next is boron oxide. So in presence of the boron oxide, it increases the melting point of the glass. Next one is lead. So the lead provides the clarity and brilliance for the glass. Next is Al2O3, aluminum trichloride. This Al2O3 increases the hardness and durability of the glass, and also it increases the chemical resistance property of the glass. So next we see the manufacturing process of the glass. So in the manufacturing process of the glass, first is blowing, and examples of blowing is caramel bottle and jar. And next process is, second one is drawing. In that rods, tubes, sheets and glasses etc. are used for manufacturing process of the glass. And third process is pressing, and last process is casting. So these are the manufacturing process of the glass, includes blowing, drawing, pressing and casting. Next is amber glass and red glass. This amber glass and red glass, it protects from the light, and this amber glass and red glass contains the Fe2O3, ferrous trioxide. This Fe2O3 into the product, that means the reaction, this Fe2O3 into the product reaction is not suitable for the product which containing iron catalyzed ingredients. Next is powdered glass. This powdered glass is performed on crushed grains, and water attack uses for evaluating the whole containers for type 2 glass that has been exposed to SO2 fumes, that means sulfur dioxide fumes. So next we see the types of glasses. So the type 1 is borosilicate glass. This borosilicate glass is more chemically resistant than other glasses. And second type of glass is treated soda lime glass. And type 3 glass is regular soda lime glass. And type 4, type non-parenteral. This type parenteral is general purpose soda lime glass. This general purpose soda lime glass is for oral or for topical use, means for your skin, and that means non-parenterals. So these glasses are most important for your GPAT exams. We revise that first type 1 glass is borosilicate glass. This borosilicate glass is more chemically resistant than other glasses. Type 2 is treated soda lime glass. Type 3 is regular soda lime glass, and type non-parenteral is general purpose soda lime glass for oral or the topical, means your skin use, that means non-parenteral. Next we see the glasses as per their types in detail. So the type 1 is borosilicate, in that the reactions in sodium is loosely combined with the silica and it reaches out with water at 10 to 15 parts per million NaOH along with traces of other ingredients, and in addition of 6% boron, this addition of 6% boron reduces the reacting action 0.5 parts per million dissolve in a reaction in type 1 borosilicate glass. This process is occurs. Next one is type 2 glass. So this type 2 glass is stored in a several months in a damp atmosphere, and in condensation of moisture to the outer surface, the salt being dissolved out of the glass in this process in a condensation, and then the blooming or weathering in presence of a characterized by the appearance of fine crystals on a glass which are washed with water or the acids. And this type 2 glass contains the soda lime which is de-alkalized called the sulfur treatments, and it prevents the weathering, and also the alkali removed the appearance as sulfur bloom as a sulfur if the alkali is removed in a type 2 treated soda lime glass. So next we see the plastic containers are made up of, so the plastics containers in a glasses, they are made up of polyethylene. So the polyethylene's density of polyethylene ranges 0.91 to 0.96, susceptible to oxidative degradation during the processing, and also the antioxidants are added like butylated hydroxyl toluene, that means your BHT, and dilauryl thiodipropionate. So the antioxidants are added like BHT, that means your butylated hydroxyl toluene, and dilauryl thiodipropionate. Next also antistatic additives are added. So these antistatic additives, they minimizes the airborne dust accumulation at the surface of the glass. So the antistatic additives minimize airborne dust accumulation at the surface of the glass. And the example of antistatic additives, they are polyethylene glycol and long chain fatty acids like amide. And the concentration of antistatic additives is 0.1 to 0.2% in high density polyethylene normally. Next one is polypropylene. So this polypropylene, this does not stress and it crack under any condition except the non-aromatic and halogenated solvents, and this polypropylene suitable for boilable package and for sterilization products. And also this polypropylene, in that the brittleness at low temperature, and this polypropylene blended with other polymers easily. And next one is polyvinyl chloride. This polyvinyl chloride PVC, your PVC pipes, like this PVC does not overheat, and this PVC is degraded at 280 degree Fahrenheit, and the degradation of the products are corrosive in PVC, and the added stabilizers, they are diacetyl tin mercaptoacetate and malate compounds, and others are sulfur, calcium and zinc salts in a PVC. And next plastic containers are made up of, the fourth is polystyrene. So the polystyrene is not useful for the liquid, and this polystyrene products has high water vapor transmission as well as high oxygen permeability, and this polystyrene used for dry products only. And this polystyrene has a low melting points, that means 190 degree Fahrenheit, and this polystyrene cannot be used for the hot items. So next is nylon. So this nylon contains the dibasic acid plus diamine. And for examples, nylon 6:10, that means 6C atom in a diamine and 10 in acid nylon. 6 and 6:10. And next one is polycarbonate. So this polycarbonate is a rigid as a glass, and this polycarbonate can be replaced with glass vials and syringes, and this can be subjected to repeated sterilization. And next one is acrylic polymers. So this acrylic polymers, this is used for the food packagings. So the acrylic polymers like acrylonitrile, methacrylonitrile, and this acrylonitrile and methacrylonitrile monomer safety standards less than 11 ppm and 0.3 parts per million for all other products. Next we see the last is other plastics. So this other plastics, in that the co-extrusion technology permits the use of high barrier resins in other plastics like polypropylene and ethylene vinyl alcohol. So this polypropylene is a moisture barrier, and this ethylene vinyl alcohol is acts as a gas barrier. So this is most important question in GPAD. The polypropylene is used as a, and right answer is moisture barrier, and ethylene vinyl alcohol act as a gas barrier. So next we see the drug plastic consideration. So in the drug plastic consideration, there are 5 considerations. They are permeation, leaching, sorption, and also chemical reaction and modifications. So in the permeation, the transmission of gases, vapors, liquid through the plastic packaging materials, and in a leaching process, the migration of constituents from containers to the drug. And in the sorption process, the sorption means the removal of constituents from the drug products by packaging the materials, and the sorption is commonly encountered loss of the preservatives. Next one is chemical reaction. In the chemical reaction, plastic formulation reacts chemically with one or more compounds of drug products after the appearance of the plastic and drugs in a chemical reaction. So in the chemical reaction, such a reaction occurs in a plastics and plastic products. So next one is modification. So in the modification, physical and chemical alteration of packaging materials by the drug products. So in the modification, there is a alteration of products, that means changing the products properties like physical into chemical, chemical into physical. So these alternative processes are added and in a materials by the drug products. The process like physical and chemical alterations in the modification. So next one is collapsible tubes. And in the collapsible tubes, first one is in collapsible tube metals use. So the metal use are aluminium, SN. This SN is most chemically inert, and PB platinum is not for good. Lead is not good for products, and lead poisoning. So this lead is not for food products because it causes the lead poisoning in a food if taken by you and other persons. So the metal use, they are also tin. So tin is alloy with 0.5% and copper for stiffening when P is used, that means platinum is used, and 3% is antimony is added to increase the hardness of the collapsible tubes and also the glass. And the tin is a preferred food packaging. It increases the hardness. And the linings, so these linings are epoxy linings, vinyl with aluminium tubes, and also the phenolics. So the phenolics are effective with acid products, and epoxides with alkaline materials and also the wax are also used for the tin, and it does not have the suck back property. So the wax are also used for tin, and this wax it does not have the suck back property. So the next we see the plastic tubes. So the plastic tubes advantages are the plastic tubes has suck back property, and this plastic tubes prevents the product O's, that means looseness O's the product, prevents product O's, and also these plastic tubes are leak proof, and these plastic tubes are also unbreakable. That means these plastic tubes they cannot be break easily, and these plastic tubes are odorless and they are inert in nature. Next disadvantages is only for plastic tube is contamination of the plastic tubes. That means contamination of plastic tube and also the plastic material contamination. And the most commonly used of this plastic tube is high and low density polyethylene. So this high and low density polyethylene is most commonly used. And the third one is lamination tubes. So this lamination tubes, the machine used is slide simmer. So in the GPAT there is a question for lamination tube which machine is used, and the right answer is side simmer. And these lamination tubes in a head made of low density polyethylene in a some permeation is possible in a lamination tube, and it reduces the product permeation. So its head insert made up of urea formaldehyde, and this reduces the product permeation. So in the lamination tube the head insert is made up of urea formaldehyde. So this is more important for GPAT. The head insert in a lamination tube they are made up of, and the right answer is your urea formaldehyde, and this urea formaldehyde reduces the product permeation. So next we see the closures. So the closures has 5 basic designs. They are screw on threaded or liquid metal or plastic. So the closures are screw on threaded or liquid metal or the plastics, and also the crimp on crowns. That means you see the thumbs up bottle, there is a crimp like structure in a opener, crimp like opener. So this crown like opener is a closure for this thumbs up bottle. So this type of closures are generally used for the soft drinks. So the next one is press. So the press closure on snaps, and also roll on closures, and also friction closures. These are the 5 basic designs for the closures. And also the filter proof closures. The filter proof closure, they are thread screw cap, lug cap, and crown caps, and roll on closures. So the lug cap. So this lug cap is widely used in the food industry because it offers the hermetic seal and handled well in a sterilization equipments is a lug cap. So the lug cap is widely used in the food industry because it offers the hermetic seal and it handled well in a sterilization equipments. Next one is closure lines. So this closure lines provides the light seal between the closure and the containers, and these closure lines may be homogeneous and or heterogeneous liner. Like the torque testing, this torque testing owns the Illinois torque tester. So for torque testing, Illinois torque tester and rubber stopper. So the rubber stopper, in that the natural neoprene and butyl rubber are used as a rubber stopper, like neoprene and butyl rubber. And the plastic closures, they are thermosettings in phenolic and urea. This phenolic in urea, and thermoplastic resin is polyethylene, polypropylene, and polystyrene. They are the thermoplastic resins used in a plastic glass containers. And the type of ingredients they are commonly found in a rubber closure are rubber and vulcanizing agents like sulfur. Sulfur acts as a vulcanizing agent, and the accelerator is 2-mercapto benzothiazole, and activator is zinc oxide, and extended filter is carbon black or the limestone, and the reinforced filter and softener or plasticizer, and also the antioxidants pigments are used. Next, last one is tempered resistant packages. So in the temper resistant packages, they are film wrappers. So the film wrappers are in three types. They are shrink wrapper, fine seal wrapper, that means in example is cellophane, and polypropylene. They are thin seal wrapper and end folded wrapper. So the end folded wrapper material use is cellophane and polypropylene. So for end folded wrapper and fine seal wrapper, the material use is cellophane and polypropylenes. So the cellophane, so this cellophane is a regenerated cellulose. This cellophane is not heat sealable, and in cellophane the heat sealing property provided by coating cellophane with polyvinylidene chloride, that means PVDC, polyvinylidene chloride, and also nitrocellulose and polypropylene. So the polypropylene is a has heat sealing property provided by the acrylic coatings or the modifiers to the resins. And the fine seal wrappers, so these fine seal wrappers like polyethylene and surline. So the fine seal wrappers are polyethylene and surlines. And next one is shrink wrappers. So these shrink wrappers are polyethylene, polypropylene and polyvinyl chloride. These are shrink wrappers. Next one is blister packaging. So this blister packaging is commonly used for the unit dosage packaging, and for blister packaging, that means unit dosage packaging, material used they are PVC, polyvinyl chloride is most commonly used, and PVC or polyethylene, polystyrene and polypropylene. And for added the moisture, they are added for the moisture protection, they are polyvinylidene chloride. This polyvinylidene chloride also known as saran, or polychlorotrifluoroethylene known as aclar, and this polyvinylidene chloride, that means saran, and polychlorotrifluoroethylene means aclar films can be laminated to the polyvinyl chloride, and the moisture barrier of polyvinyl chloride or aclar is superior to that of saran coated polyvinyl chloride, especially under the prolonged and extremely humid storage conditions. So, and also the third one is strip packaging. So this strip packaging is generally used for the tablets and capsules. So this strip packaging is majorly used for your tablets and capsule dosage forms, and the material used in the strip packaging, they are for high barrier applications paper or polyvinylidene, and also foil and polyethylene laminations are their material used in a strip packaging. And for product visibility, the heat sealable cellophane or heat sealable polyester can be used for product visibility, cellophane or heat sealable polyester. And foil paper or plastic pouches, for foil paper or plastic pouches, these are effective sealant as polyethylene, ethylene vinyl acetate and surline. So these are the foil paper or plastic pouches. And last one is most common cations found in a glass. They are silicon, aluminum, boron, sodium, potassium, calcium, magnesium, barium and iron. So rubidium. And note that this blowing, so the blowing is a use, this blowing uses in a compressed air to form the molten glass in a cavity of a metal mold, and the drawing is used in a molten glass is poured through dies or rollers that shapes the glass is known as drawing, and blowing is uses the compressed air to form molten glass in a cavity of a metal mold, and the pressing is a mechanically force is used to press the molten glass against the side of a mold. So the name is enough for the pressing. So the pressing is a process of the only force force is used to the press is known as pressing. And the bubble pack. So the bubble pack is usually formed by sandwiching the products, means the mixing the products between a thermolabile, extensible or heat shrinkable plastic films and a rigid backing materials. So in this way we completed this topic packaging. So in the packaging we see the various different types of containers like glass, and in a glass there are four types of glass: borosilicate glass, first, second treated soda lime glass, third regular soda lime glass, and fourth one is non-parenteral. This is general purpose soda lime glass. And also we see the plastic containers they are made up of polyethylene, polypropylene, PVC, polyvinyl chloride, polystyrene, nylon, polycarbonate and acrylic polymers, and other plastics like polypropylene and ethylene vinyl alcohol. And next we see the drug plastic consideration. They are permeation, leaching, sorption and chemical reaction and modification. So next we see the collapsible tubes. In collapsible tube metal used are aluminum, tins. And next we see the plastic tubes advantages, disadvantages and lamination tubes. So lamination tube, the machine used for the lamination tube is side seamer. Next at last we see the closures. There are 5 basic types of closures. They are screw on threaded or plastic, liquid metal or plastic closures, scrimp on crowns and press on snap, roll on closures, friction closures and filter proof closures. They are threaded, screw cap, lug cap, crown caps, roll on closures. And next we see the temper resistant packages. They are film wrappers like folded wrapper, fine seal wrapper and shrink wrapper. Material used, they are cellophane and polypropylene. And also blister packaging. This blister packaging is for unit dose packaging, and material used for this PVC most commonly used. So in the GPAT there is a question which is most commonly used blister packaging material, and the right answer is your PVC, polyvinyl chloride, and PVC, polyethylene, polystyrene and polypropylene. And next we see the strip packaging. So the strip packaging is generally used for the tablets and capsules. So here is the end of this chapter, packaging. So hope you like this chapter, packaging. Hope you like this video. Please, if you like this video, please comment on comment section, and please like, share and subscribe to our channel PharmaXtech, and stay tuned with PharmaXtech and stay connected with PharmaXtech for latest updates. Thank you for watching this video, and please share this video to more and more to your GPAT aspirants and CET aspirants. Thank you for watching this video. Thank you. Today is our Sunday blockbuster.